We are seeing things better in more detail than ever before, and this telescope is going to be among its many abilities. It'll be able to measure the chemistry of the atmosphere of exoplanets that pass in front of their host star. Astrophysicists just stumbled upon a series of staggering discoveries from the James Webb Space Telescope this year, and it has left them dumbfounded. The infamous telescope of unreal capabilities, James Webb Space Telescope, or JWST for short, once again searched the cosmos high and low. A continued exploration of space, this time, however, they found some anomalies in the fabric of the universe that cannot be explained by the science we have come up with on Earth yet. What were these? Neil deGrasse Tyson talking on the JWST discoveries. How did JWST make these observations in the first place? Join us as we explore the new possibilities of the nature of space as revealed by JWST and what these possibilities entail for Earth. Neil deGrasse Tyson talking on the James Webb Space Telescope. The James Webb Space Telescope has been a subject of intense discussion and speculation since even before its completion. Understandably so, the telescope is our most personal weapon in the arsenal, leading us to places humans 100 years ago would not have even dreamed of in their wildest imaginations. One of the people who talked extensively on the JWST is Neil deGrasse Tyson. The infamous astrophysicist has not shied away from the subject of the telescope, enthusiastically drumming up debates and ideas around the subject. One such event was at the 25th Annual Isaac Asimov Memorial Debate, where John Wise, professor in the School of Physics and director of the Center for Relativistic Astrophysics, joined Neil deGrasse Tyson, another physics and space enthusiast and scientist, for a thrilling discussion. Wise and Tyson spoke about the JWST's impact on astrophysics, more specifically on our understanding of black holes and how they form. On the panel, Tyson asked a simple question to the panelists. Has the JWST changed astrophysics in any way? What ensued was an enthralling discussion amongst well-read people in the field, pitching in their 2 cents on the subject. Moreover, Tyson has not made light of his enthusiasm towards the JWST. On July 11, 2022, Neil captured his reaction to some of the first images dropped from the JWST showing elation. "Oh my gosh, the first image from the James Webb Space Telescope, and here it is. Galaxies to the edge of time. Oh my gosh." He further went on to explain that the telescope can be used to observe the literal birth of galaxies through the power of infrared radiation. NASA astronomer Natalie Batalha added that the JWST can potentially bring back the potential traces of the very first supernova that went off in the universe, making the whole affair all the more intriguing. By far, the most interesting thing Tyson has emphasized in relation to the JWST is the fact that, unlike the Hubble telescope, something that orbited Earth a mere 360 miles away from the surface of our planet, the JWST is stationary. Not just that, the JWST is parked about a whopping 1,000,000 miles away from Earth in the opposite direction of the Sun, orbiting the Earth and the Sun together. This brings up the fact that the JWST is able to quite literally look into the past of the universe, bringing us snapshots of things that happened and allowing us to fill in the gaps in the storyline. When the JWST is fully expanded, its sun shield comes up to about 72 by 40 feet. This is also the JWST's largest feature, designed to fold about 12 times to make it more compact and tiny. Fitting a machine as big as the JWST was quite a task, and the engineering that went behind making it fit within the Ariane 5 rocket as it made its way over to L2, which is a Lagrange point, was outstanding. What is a Lagrange point? It is the point where the JWST would have been able to maintain a gravitationally stable and sound orbit within the solar system. Tyson explained to Popular Mechanics how difficult it was to deploy the telescope, detailing how the engineers went through the process of figuring out a way of unfurling the telescope so that it could fit in the fairing of the rocket. Moreover, heavy shields had to be deployed just so that the temperature of the JWST could drop to almost near absolute zero 1,000,000 miles away from Earth, basically assimilating to the temperature of space itself. However, there was another thought-provoking thing about the JWST. Tyson elucidated that there was a possible gap in the space-time continuum we observed through our telescopes. This gap was the era in time when nothing on this Earth could retrieve data of high quality. This stage happened early on in the universe when human innovation was in its infancy, taking little steps at a time. Why is this so? There is a simple answer to this question. You see, when stars and galaxies are born, They emit radiation in the form of ultraviolet light. As these stars and galaxies travel through space, a place that is not static but instead has been expanding since the dawn of time, the light waves that were emitted end up stretching. This stretching results in longer wavelengths, and by the time it reaches our planet, it is fully transformed into infrared radiation. Leading with this, Tyson claimed that the images that the JWST has been showing us, such as the galaxies that formed around 13 billion years ago, are portals to the past. So how do you even fathom the morbid fact that we might be looking at pictures of celestial objects that existed so far in the past? Tyson provides another excellent answer to that question, using an illustration to explain why astrophysicists do not seem to be too worried about objects far, far away from us existing or not. He delineates that if two people were in the same room and an arm's length away from each other, person 1 would not see person 2 as they are. What will happen instead is that person 1 will see person 2 as they were 3 billionths of a second ago. Mind-boggling, isn't it? He adds further that because human beings can only live up to some decades, 10 if they are lucky, that kind of time simply is not enough to induce any significant or meaningful change in a person. What if, instead of an arm's length away, you made the two people stand 384,000 minutes away? Maybe once that person is on a star, significant change will be seen. For example, a person standing on a nearby star would appear 20 years into the past. That person would not be able to see you for 2 decades, a significant chunk of human life. Tyson says that for most stars residing in our galaxy, the time it takes for their light to reach us is short compared to how long they live. So worrying about whether the star whose light we see today is different from what it's doing right now is futile. Astrophysicists now use telescopes like the JWST to see stars that exploded thousands or millions of years ago, in a way observing the ghosts of stars that might not exist today. That begs the question, what ghosts has the JWST captured earlier this year that have stumped the scientists? The Orion Nebula. Earlier this year, the JWST brought forth new images of the Orion Nebula, shedding light on a formerly well-researched yet hardly understood celestial object. These new images display the cloud of gas and dust responsible for star formation in a more detailed view. Firstly, what is the Orion Nebula? The Orion Nebula, a celestial object located close to 1,500 light-years away, is also known as Messier 42 or M42. It is located towards the constellation of Orion, making it the closest star-forming nursery to our solar system. According to the science communication website The Planet, the Orion Nebula is part of one of the most active regions in the case of star formation visible in the sky, known as the Orion Molecular Cloud Complex. This is also sometimes referred to as the Orion Complex, and it is one fascinating celestial body to grace our observations. Why is it fascinating? Well, researchers have claimed that the Orion Complex is comprised of several molecular clouds. These include the Lambda Orionis clouds, the Orion A cloud, and the Orion B cloud. The Orion A cloud contains the Orion Nebula, while the Orion B cloud houses the Flame Nebula. As stated in the Astrophysical Journal back in 2006, the Hubble Space Telescope managed to capture the clearest view of the Orion Nebula which had never been seen before. According to the European Space Agency, this image revealed more than a whopping 3,000 stars, some being observed for the very first time. Moreover, in 2016, we found ourselves with the deepest as well as the most comprehensive image showing the Orion Nebula that revealed some interesting things, reported on space.com. The image showed some more planet-mass objects as well as brown dwarfs. However, not every star that is seen in the Orion Nebula is considered successful, meaning a ton of brown dwarfs have been found courtesy of the Hubble Space Telescope. Why are brown dwarfs called brown dwarfs? Failed stars. The failure in question here is attributed to their size. More specifically, their size is so small that they cannot sustain the nuclear fusion that happens at the core of the stars. According to NASA, brown dwarfs are not big enough to be called stars. However, they are not small enough to be considered planets as well. They are awkwardly stuck somewhere in between, being 13 to 80 times the approximate mass of Jupiter. Back to the Orion Nebula. It has been studied to the stars and back, especially because it is visible to the naked eye when the skies are dark. The recent JWST images showcase the James Webb Space Telescope's power, particularly in zooming in on a diagonal ridge-like structure of gas, and dust situated at the lower left quadrant of the nebula. This feature is officially known as the Orion Bar. The Orion Bar area is one of the most studied parts of the Orion Nebula, with over 50 protoplanetary disks visible in just the snapshot sent by the JWST. Several bright stars in the region highlight another area known as the Orion Bar, named after the bright bar-like structure at its center. Captured by the JWST, this bar is where powerful photons from nearby trapezium stars break apart the surrounding molecular cloud, causing the entire surface of the Orion Nebula to exhibit the same pattern. Interestingly, despite this uniformity, the Orion Bar appears much brighter due to its special shape, with the trapezium stars creating a canyon-like area inside the nebula. In the picture, we're observing almost edge-on at the canyon wall of the bar, making the bright bar-like structure visible through nearly any telescope. Just south of the bar, two bright finger-like structures, HH203 and HH24, can be seen, named after astronomers George Herbig and Guillermo Haro. These Herbig-Haro objects are bright spots in star-forming areas, typically caused by jets or gas from young stars, although the young star responsible for HH203 and HH24 has yet to be identified. What truly caught the eye in the images of the Orion Bar was its unique geometry. The detailed layers in the images provided tremendous insight into the physical and chemical composition of the region, revealing different regions from the harshly ionized and highly exposed Orion Bar to the more sheltered areas where molecular gas can potentially form. These observations shed light on the unique behavior of this constellation, according to Yang Kamami, a researcher at Western University. As we continue our exploration into space, we encounter phenomena far more intriguing than naked-eye constellations. In early September 2023, the JWST contributed to the ongoing debates surrounding the universe's expansion rate, revealing universal asymmetry. While scientists have long known the universe expands outward in all directions, unanswered questions remain as we observe stars and galaxies drifting farther apart from each other and their origin points. This dynamic nature of the universe poses challenges for observational research, such as accurately determining the rate at which we are moving away from each other. Discovered in the late 1990s, this accelerating expansion could be attributed to dark energy, a mysterious force that affects the fabric of space-time, leaving many questions about the universe unanswered. Despite these challenges, scientists are persistent in their quest for understanding. On September 12, 2024, the JWST made significant contributions to this debate, deepening the mystery rather than resolving it. The primary issue lies in calculating the rate of universe expansion, centered around a single constant known as the Hubble constant. This value is crucial in understanding the universe's expansion rate, yet obtaining an accurate measurement has proven elusive. The Hubble Space Telescope, crucial in resolving this tension, measures stellar brightness with exceptional accuracy from its vantage point above Earth, free from atmospheric interference. This capability is essential for calculating the Hubble constant, which was once uncertain before Hubble's launch in 1990. The uncertainty was so high that astronomers couldn't determine if the universe had been expanding for 10 billion or 20 billion years. By focusing on Cepheid stars, supergiants with 100,000 times the luminosity of our Sun, the Hubble telescope measures distances to galaxies over 100 million light-years away, crucial for determining the Hubble constant. However, Hubble has limitations, particularly in its sensitivity to infrared light, which is crucial for observing distant objects unaffected by interstellar dust. This is where the JWST, with its advanced infrared capabilities, comes into play. Costing $10 billion and positioned 1 million miles away from Earth, the JWST provides a clear infrared view of the universe, enhancing our understanding of cosmic phenomena like never before. The JWST's ability to calibrate observations of Cepheid stars in galaxies with known distances and study supernovae further validates Hubble's measurements, confirming that the Hubble telescope is indeed accurate. Despite these advancements, the fundamental questions remain, challenging our understanding of the universe's true nature. The JWST continues to unravel mysteries, recently capturing highly detailed images of 19 nearby spiral galaxies, revealing millions of stars in blue tones spread throughout spiral arms or clustered in star clusters. These images also highlight glowing dust around stars and large spherical shells of gas and dust. Dr. Thomas Williams, leading the data processing for these images, expressed excitement about their potential to fill gaps in our understanding of galaxy structure and star formation cycles. Additionally, the JWST uncovered a dwarf irregular galaxy, IWI-8, bursting with star formation, located about 59 million light-years from Earth. This galaxy offers insights into the early universe's conditions, resembling the first star-forming galaxies. While these discoveries don't provide all the answers, tools like the JWST bring us closer to unraveling the mysteries of our origin and understanding ourselves better. What are your thoughts on these JWST findings? Do they bring us closer to answering the universe's mysteries? Let us know in the comments, and don't forget to like and subscribe.